Okay, so the moment you have all been waiting for, well, at least some of you, since you signed up for this course, black holes. And so, neutron stars, right? They're basically neutrons packed so close together that they can't collapse, right? And then we found out that maybe they could merge, and then you'd get this giant fireball. Um, but what if they could collapse? In order for a neutron star to be a neutron star, it can't be more than 3 stellar masses, or 3 times the mass of our sun. Above this limit, neutrons can't fight the power of gravity. So gravity wins the battle and starts to compress this even more. Now, we know this happens for sure at 25 stellar masses, or 25 times the mass of our sun. So, again, it's not going to happen to our sun, but if our sun was 25 times bigger, it could. So, large mass, more gravity. Gravity is so strong that it pulls everything in, right? The neutrons are collapsing, everything around it, even the light and radiation is being pulled into this. Nothing can escape the power of gravity at this point. And so to us, it appears as though there is a black hole in space. And that's what we call it, a black hole. So black hole is basically something that has so much gravity that nothing is escaping it. Well, what do you mean nothing's escaping it? We talked about the escape speed before. So what is the escape speed? Well, for a black hole, the escape speed is larger than the speed of light. Now going back to Einstein, right? Einstein's theory of relativity says that nothing can go faster than the speed of light. Nothing. So gravity is attracting everything in this black hole, and that means that it's not being able to escape, so your escape velocity is greater than the speed of light. Now, again, just to remind you, your escape speed, escape velocity is how fast an object has to travel in order to escape the pull of gravity from another body. So for Earth, it's 11 kilometers per second. Right? But for a black hole, it would be larger than 300,000 kilometers per second, and nothing goes faster than 300,000 kilometers per second. All right, so let's look at the escape speed just a little bit in more detail here. So the escape speed is proportional to the mass of the body. I want to say how big, but that's not quite true. The mass of the body, that's how much mass there is, divided by how big it is. So your escape speed is going to go up if your mass goes up. Right? So if you have more mass, you've got more gravity, your escape speed has to increase. However, if you take that same mass and you squish it down, you decrease the radius, then your escape speed will also go up. So if we look at Earth, Earth has approximately 11 kilometers per second escape speed. Now, if you were to shrink the Earth to a quarter of the size, the escape speed would double to 22 kilometers per second. If you take Earth and you shrink it to a kilometer, the escape speed is going to be 700 kilometers per second. But if you shrink Earth to 2 centimeters, right, that's less than an inch because an inch is 2.5. 2 centimeters. You take all of Earth, don't lose any mass, just shrink it down. The escape speed will be the speed of light. Now, the speed of light is pretty darn fast, but if you want to ensure that nothing is going to escape, if you want to make sure it's a black hole, then you have to shrink Earth down to just below 2 centimeters. It doesn't have to be much below, just a smidgen below, and you will have a black hole because the escape speed will be greater than the speed of light. So nothing can escape, not even EM radiation, visible light, any type of radiation or light that you want to name, it's not going to be able to escape. And so therefore we have a black hole.